1 hour only. No lah, guys. My aim is to finish the whole paper, okay? Finish the whole paper. I don't care until what time, okay? I need to finish the whole paper. Okay. So guys, are you ready? Because I am actually okay. Okay. So now, so on what is happening here is okay, we have something like this, guys. So let's start. Let's start. So everyone get your notes ready. Hope can tahan. Can. Okay, come. So guys, on what we are seeing for today on this material here is basically your SBP SPM trial past year from last year. Okay, SPM 2025. Yeah. So in the first question, actually we haven't learned this fully in our class because in our normal class we learn about natural rubber, we learn about vulcanized rubber. Okay, so we actually haven't learned this thing called the synthetic rubber. You're supposed to learn this synthetic rubber next week, okay, in the next week class. So but then because I do pass confirm got some topic you haven't learned before, okay. So this one is actually just some questions that you all haven't covered in our normal class syllabus. So you all never mind. I will just go through with you. For those who are not yet learning, I will let you know. Okay, but for those who learn already, then we supposed to know how to answer lah. Okay, so this paper I checked already. It doesn't have a lot of questions that you all haven't learned before. So most of the questions you all learned before already. So let me try to revise overall lah. Okay, so for the first one called synthetic rubber, where synthetic rubber you can see to make your cooking utensils, okay, all the cooking all the tongs and stuff, okay. Then we have natural rubber to make gloves, to make rubber band, okay. So this one very fresh, right? You all learned this in the last class. We have natural rubber, we have like the normal rubbers, okay. So the idea here is that they ask you state one characteristic of synthetic rubber and natural rubber. So guys, as we all learn natural rubber, so what is the properties of natural rubber? So I think you all can relate to natural rubber first. So you can say what? So natural rubber, if you remember, it's a soft white solid. So I think the first answer can be soft. Okay, soft. Okay, then you can say elastic. These are the few common properties of your natural rubber. The next thing is we have your synthetic rubber. So for synthetic rubber is what? Synthetic basically is what? It's man-made. But this man-made rubber, basically it doesn't actually contain any latex, okay, or any isoprene. Okay. So what we can say is for synthetic rubber, if you want to remember synthetic rubber properties, right, you can remember the same thing as your vulcanized rubber. So anything vulcanized rubber got, synthetic rubber also got. Because why? Because in overall, in our synthetic rubber is just better than vulcanized rubber, but he got everything vulcanized rubber got lah. So we can say what? So a lot of people, you all say that. You all can say high resistant to heat, can hard. Okay, so got many answers lah. Guys, means you can say similar to your vulcanized rubber, but it better than vulcanized rubber. Okay, better version of vulcanized rubber, better version of vulcanized rubber. So whatever vulcanized rubber got, he also got. Okay, synthetic rubber also got lah. Can okay, can I write the low melting point? You mean this one? The soft and elastic? Cannot. Okay, low melting point, usually you can just say low heat resistant. Okay, in rubber, we say heat resistant. Okay, highly heat resistant or low heat resistant. Okay, try to go with heat resistant this term. All good. Okay, what's the difference between vulcanized and synthetic? Aren't they both man-made? No. Vulcanized means you take natural rubber, you make it better. You add something chemical, you add some chemical to make it stronger, to make it better. But synthetic is not made from natural rubber. Synthetic is like made from petroleum. Okay, you get the idea? Means no use rubber at all. But we use petroleum to make something got elastic, then it is synthetic rubber. Okay, so that's the difference from here. Okay, can we write high resistant to heat for synthetic? Can. You can say high heat resistant. Can. So this one high heat resistant. Okay, so this one is to relate your rubber a little bit. Then going down, state the name of natural rubber polymer. Guys, 2 weeks ago in our normal class, we just learned this. So 2 weeks ago, what do we call this? Isoprene. Guys, if you write isoprene, congratulations. You almost there. You know why? Because isoprene is the monomer. They want the polymer. See? Everyone wrong with you? GG. Okay, so you all fall into the trap. You say, okay, teacher, natural rubber, okay, isoprene. But guys, supposed to be polyisoprene. Okay, isoprene is a good try. Isoprene is a good try. But I know it's a very important trap. Okay, it's a very tricky trap. Okay, so it's polyisoprene. You never put the word poly, it's not a polymer. Okay, if you actually say they want the name of natural rubber monomer, then you can say isoprene. Okay, if I write the IUPAC answer, can. What guys? Do you know what is the IUPAC answer? Some of you say, teacher, can we write the IUPAC? Can. I mean, really got people know one so it's actually poly, okay, methyl, okay, actually, in our book, right, we say poly, 2-methyl, but 1,3-diene. Okay, so this one is the answer. Okay, but the two basically is not very important. The two is there, that it doesn't really matter lah. Okay, so this one also can. For those who want to show off, okay, this one okay, can. Okay, so to put the word poly in front, poly 2-methyl but 1,3-diene. Okay, all good, something methyl but 1,3-diene. Okay, so all good. So if okay, guys, no issue. The very long name. Thank you, the long name. Okay, going down next page. What is synthetic rubber? Okay, guys, since we haven't learned synthetic rubber X, okay, so but something that we learned in the beginning of this chapter when we learn rubber, we actually learned before one of the type of polymer to make your cooking utensil that is actually having the properties of elasticity. So for this elasticity, basically, is under the material of silicon. Okay, we use silicon to make synthetic rubber that is used for cooking utensil. But we haven't learned this in details, so you're supposed to learn this next week. Okay, can teacher, this one pass here or just practice paper? This one pass here from SBP. SBP is those sekolah asrama penuh. Okay, the asrama school lah. Okay, so I'm just doing their past here. Okay, just going through everything lah. State the name of the process to improve the characteristic of natural rubber so it has a better quality and lasts longer. So guys, I think this one you all are familiar because we just learned this literally last week. Okay, so we can call it the vulcanization. Okay, vulcanization. Vulcanization. Addition of sulfur link. This one too much. They just want the process name. Process name, we just call it vulcanization. Okay, vulcanization. Oh, good. Okay, what if I spell it as vulcanization? The Z, S change to Z, can. Also can. Okay, that one is the England and the US spelling different. Okay. Teacher, what about condensation and addition? You mean this one? No, because this one is to actually your word you say condensation and addition. That one is a type of polymerization. So that is the process to make polymer. But this one not asking you to make polymer. This one is asking you how your natural rubber become better. So it means you add the sulfur. You add sulfur, become sulfur cross-link. That one is called vulcanization. Can we say add metal peroxide? Irradiation? Cannot. Just go with vulcanization, okay? Don't try to show off. Hey. Okay, teacher, is it silicon or silicon? With the E or no E? Doesn't matter, guys. Again, England and the American spelling doesn't matter. Okay, so going down to the next one, we have this picture. I think we've done this before, okay, very long ago. Okay, for those who learned, those who took booster, right? This one is similar. So what is the type of particle for ammonium ion? So this is actually an ammonium ion. So the difference you see is the N share electron to the two dots, okay, to your H. And then you also got dot cross, and dot cross. Right now. So the dot cross right here, what we know is this is bond Y, this is bond Z. So the idea is what? The idea is the two dot is where you share electron only coming from one side. But the dot cross means you share electron from both sides. Okay, means let's say if the N gives you one dot, the H gives you one cross. So this is a normal sharing that comes from both sides. We call this the covalent bond. Okay now. But if you have electron that only come from one side, means dot, let's say the dot is from nitrogen. So the nitrogen share two electrons, but the H of this is not contributing at all. So this is a pair of sharing electron that only one side contributing. So we call this the dative bond. Okay, we call it the dative bond. So now in this case, say the type of particle for the ammonium ion, guys. When I say type of particle, don't say solid, liquid, gas. That one is called physical state. Okay, so when I say type of particle, we got AIM. What is AIM? AIM stands for AIM, atom, ion, molecule. Okay. So right now, do you see here got positive charge? Means that this is supposed to be ion. Okay, ion, no issue, ion. Okay, so moving down, we have what are the elements found in ammonium ion? So in the whole thing, what are the two elements? One is H, one is N. Okay, so we have nitrogen and hydrogen. Okay, guys, before I continue, one thing, guys, you all private chat me. I actually very hard to see. Okay, too many people private chat me. I cannot one by one click. Okay, so if you all want to chat me, I just you all chat in the general. Okay, I cannot afford to click one by one already. I need to go slightly faster. Okay, so guys, general. Okay, any question just ask. Okay, so now in the general chat, guys. So the private chat I don't see it here. No time. Okay, can I write the symbol for it? You mean this one? No symbol. No symbol. When they ask you what are elements, you go with the name. Okay. Okay. Because this question, right, they never specify, right? They never say name or they never say the symbol. So what happened is, if you want to put name also can, you want to put symbol actually also can one. But some teacher they insist if they never specify write formula, then you write name. Okay, so some teacher a bit tricky on this is writing name is always the best choice unless the question say write chemical formula or write the chemical symbol. Okay, can we write hydrogen only? Cannot, because elements found. If you write hydrogen, no mark. You must write both, only can get 1 mark. Okay, okay. Now state the chemical formula of ammonium ion. It's 1N comes with 4H, so therefore is NH4 with a plus. Okay, and then what we can say, the 2 dots is dative bond. The dot cross is the covalent bond. So we can say this is Y is dative bond, while your X, wait. Y is covalent. Almost. I thought X is the other one. So Y is covalent bond, while your Z is the 2 dot is dative bond. Okay, so I think this one no issue. Okay, going down on question 3, what is meant by nuclear number? So guys, I think this definition you all have it in your mind for a very long time already, since Form 4, the first exam. I always ask you all to memorize this. If it doesn't come out in SPM, very easy to score. But there are some tricky part that you might miss out. What is the tricky definition from here? So what is meant by nuclear number? You all can say is the total number of two things, of protons and neutrons. But if you stop here, no mark. You must say in the nucleus of an atom. Okay, in the nucleus of an atom. Okay, can so this one must go like this. I must say in the nucleus of an atom. Then going down, write the electron arrangement of ion P. This one also very tricky, because if you go P, P, if you want to write electron arrangement, you by right you look at the proton. So got 11 proton, you'll be like, okay, teacher, 2.8.1. So this is also a very common mistake that made by everyone. So what happened is, you look at the keyword is ion. Ion means what? Ion means it's supposed to have charge. And when do you actually get charge? Charge only happens when you lose or gain electron until stable. So is this 2.8.1 stable? No. So ion P is not, because this is atom P. 2.8.1 is atom P. Not yet lose electron. So ion means you have to lose electron. So your answer here should be just 2.8. Okay, 2.8. Do we get marks if you don't write total? No. Total must put. Okay, total must put, because it's two things add together. Okay, total must put. Okay. Okay. Draw the atomic structure. How do you know it receive or release electron? This question. Less than 4. Valence electron less than 4, lose electron. Valence electron more than 4, you gain electron. Valence electron equal to 4, you share electron. Okay. So less than 4 lose, more than 4 gain, and then just nice is 4 will be sharing. So here is ion P, so he lose the 1 electron, he will be 2.8. Okay, 2.8. Next one is to draw atomic structure of element R. Okay, so element R, no charge. We just go with R. It's 12. So by right, 12 is 2.8.2. So you're going to draw 2.8.2 lah. But one thing is, what is atomic structure? Atomic structure, it means you must draw out the nucleus and label proton and neutron. Okay, it means you see, got 12 proton and nucleon number is 24. So how many neutron? You take 24 minus the proton. So actually you got 12 neutron. Okay, so let's say if I were to list out neutron, neutron, how to find? 23 minus 11, this is 12. 24 minus 11, this is 13. 24 minus 12, this is 12. Okay, like that. Okay, So now R got 12 neutrons. So what you do in atomic structure, your nucleus in the middle, you label 12 proton, 12 neutron. This is your nucleus. Okay. Then you go to draw your electron arrangement. So 2.8. 1, 2, 3, 4, 5, 6, 7, 8.2. And guys, 2, how to draw? How to draw 2 electron? Must be separate. Okay. Up, down, left, right. Okay. That doesn't matter as long you don't draw like this. You draw your 2 electrons like this. Wrong. Okay. Must separate your 2 electrons. Okay. So this is to our 2.8.2. Can we terbalik the N and P position? You mean neutron on the top? Can. Neutron at bottom, up and down doesn't matter. All good. Can. So this time moving on. We have a picture to show you the leakage of pipe, underground piping. Which element is the most suitable to be used on the instrument to detect leakage? And so for here is, what happened here? What is the isotope? If you remember, this topic is under isotope. So we call this the sodium 24. iodine 131. Iodine 131, that one's for thyroid disease. Okay, to treat thyroid disease. Do we have to shade the middle, or you mean the nucleus? No need. Okay, no need. If your teacher asks you to shade, that one is basically just extra stuff. Okay, you can just leave it empty at this. Okay, can all good. No need to shade. No need to shade. This one is teacher aesthetic purposes. Okay, some teacher like this, she insists like this. No need. This one too extra. Okay, even if you do like symbol, let's say example, let's say this is element R, the nucleus is like this. Just like this. No need to shade at all. Okay, no need to shade one. Shading is never in your marking scheme say must shade. Okay. So this is the idea. Okay, no issue. Okay, so okay, moving on. Okay, moving down. State one disadvantage of instrument use. So guys, if you remember all these detecting leakage, okay, detecting the age of your, technically it's all isotope. And what's the specific topic about the isotope? We call them the radioisotope. And if they are radioisotope, what is the general disadvantage of all radioisotope? They are all radiation. Okay, got radiation. So in a better word, we call it radioactive. Okay, radioactive means got active radiation. Okay, expensive. Way. No lah, not so expensive. Okay, actually a lot of stuff not expensive as you think. Okay, so radioactive. Okay, got radiation. Okay, moving down, we have oxygen gas burns, investigate the chemical properties of group 1 element in the periodic table of elements. So guys, this is a group 1 element. So Q can be what? Can be lithium, sodium, potassium. So group 1 lithium, sodium, potassium. Then add water after. Okay, so usually when we do in this gas jar, right? Gas jar, what they will do is they will burn with oxygen. So we have one experiment where you take your lithium, sodium, potassium, you burn with oxygen to get the different gas, different flame color. If you remember that. So if you remember, is the flame color is what? It just like your traffic light. Okay, it's red, yellow, but the last one is lilac. Okay, so if you burn with oxygen, it gets you red flame, yellow flame, and lilac flame. Okay, so if you burn this, you might get different color flame. Then you add water. You throw that after you burn, you take the chemical and dissolve in water. You get a QOH solution, which is OH is what? OH is alkaline. Okay, so these are all the information we can get from the question. So now state one method to store group 1 element in laboratory. So guys, I think this one very good. You keep or you store in this oil called paraffin oil. Correct. So this one very common question in the exam. Hopefully you all can score if they come out. Write a chemical equation. Guys, this is the worst. This is the one of the many questions that a lot of students actually cannot score. So they say, teacher, write chemical equation for Q and oxygen gas. So first of all, guys, what is Q? Q is Q. Okay, but there are chances. The question is, do you need to have Q2? Sometimes your unknown element. Sometimes if you see our equation got 2. Sometimes you see no 2. Guys, the idea is what? 2 only happens for gas. So, do you think Q, group 1, is a gas? No. So, Q shouldn't have a 2. But if you're unknown in future, if you get like chlorine, let's say I have an unknown X, it's actually group 17 element. So group 17 element must be a gas, must be diatomic kind. So that time X will be X2. You get a difference there? Okay, so this difference right here, this idea here is you take Q plus O2, you get what? What do you form? Okay, someone in the group chat say Q2O. Guys, congratulations, Q2O is actually correct. But why Q2O? Because how to determine the product form at the right hand side? It depends on the charge of your ions. So means that Q is actually plus and O is 2 minus. So when you swap, you get Q2O. Now the question is, how I know Q is plus? Why Q cannot be 2 plus? Why cannot be 3 plus? Because as we know, Q is group 1 element. So if group 1 element, the valence electron is always 1. Example like 2.1, 2.8.1, 2.8.8.1. So do you see everyone is 1 loose electron? And when they all lose electron, they become plus, plus, plus. So Q, no matter is who, must be plus. So Q plus, swap your charge, you get Q2O. Okay? So if you manage to get this equation, you get 1 mark already. Then you balance your equation, the second mark comes in. So when you balance the equation, you get 2 and 4. Okay? So 2Q2O and 4Q. Okay, all good, all good. Okay, so if this one no issue, moving on the next one is calculate mass of compound form when 0.08 mole of element Q reacts completely with oxygen. Okay, so guys, based on the equation, what we have right now is 0.08 mole of Q, but they want the mass of compound. So I want the mass of Q2O, but I have 0.08 mole of Q. So the thing is, guys, I want to find mass, I need the mole of Q2O first. Correct. If not, how to find mass? You all say, teacher, I know, mass over molar mass. But mass over molar mass, you need number of mole. And so we first need to find number of mole of the Q2O. But how do I relate to the Q2O? By ratio. Okay, so the ratio between Q and Q2O is 4 to 2. So what can we write in exam? So in exam, you can write in this way. So the ratio between Q to Q2O, the ratio is 4 to 2. So if the ratio is 4 to 2, then you put 0.08. And what is the answer here? So if Q to Q2O is 4 become 2, means divide 2, means your Q2O is 0.04. So you can write out number of mole of Q2O is equal to 0.04 mole. Okay, but as I said, guys, some of the teacher, they insist to write sentence. The teacher said, I don't want this ratio format. I want to write in sentence. Just write in sentence. You just put into words 4 mole of Q produces 2 mole of Q2O. Then 0.08 mole of Q produces 0.04 mole of Q2O. Okay now, so since I have 0.04 mole of Q2O, then I take the 0.04, convert to mass. So my next step will be number of mole of Q2O equals to mass over molar mass. So number of mole that we found here, put it in 0.04. And the molar mass follow the formula of the compound, guys. It means if you actually write the wrong formula in the equation, then GG already. You know why? Because your equation wrong, your calculation molar mass also wrong. And in okay, someone asked, in SPM, we don't have to write sentence? No need. In SPM, guys, marking scheme already show. Like this, right? Got mark. But must put unit. You must put unit like this. 4 mole, 2 mole, 0.808 mole, 0.04 mole. Must put unit. No need to write sentence in SPM. Already acceptable everywhere. But some teachers still insist to write sentence. You just go say sentence. Sentence is always correct one. Okay, so following back to your molar mass, Q2O is 39 times 2 plus 16. Okay, so guys, this one you all do the maths. So you bring your number over, multiply 0.04. Okay, anyone got the numbers with you? If no, then I do myself. 39 times 2 plus 16. 94 times the 0.04 is your final answer. Okay, many of you give me an answer already. So guys, in exam, right, please write in full. So mass of Q2O equal to 3.76 gram. Congratulations with the unit gram, very important. Okay, and guys, one thing, all this NOM in exam, please don't write NOM. I slap you. NOM must be a full name, number of mole. Okay, must write number of mole. If not, teacher can minus a mark. Okay, don't write NOM. Okay, so if there's no issue, predict the pH value of QOH form. Give one reason. Guys, what is pH value of QOH? So we can have LiOH and AOH, KOH. But it doesn't matter, guys. No matter what kind of OH, all these are strong alkaline. And they are strong alkaline. What is the pH? So we can say that pH 8 to 14 cannot. You know why 8 to 14 cannot? Because if got OH, definitely it's a strong acid. Strong alkaline. So weak alkaline only got who? Weak alkaline only got ammonia, the one without OH. You get the idea? So if must be strong alkaline, must be above 11. Okay, technically you can go with 12, 13, or 14. Okay? And give one reason. So of course, now we don't have to go with the idea of strong alkaline. We just say that this thing is alkaline. Okay, but what is the definition of alkaline? So we can say that it ionizes in water to produce hydroxide ions that shows alkaline properties. Okay, I want to ask why sometimes when doing mole calculation, you don't have to times the number of particle for the molar mass. Times the number of particle. You mean what? You mean the Q2O, the 2 in front? Is that what you are trying to say? Why don't we times 2 at the molar mass? In molar mass, you never times any number in the front one. Molar mass is always just the chemical formula. Never we do this because the number in the front is for ratio. Molar mass never times 4, never times 2 one. No number, no times any number one. Molar mass don't times any big number. Big number is only just for ratio. Okay? Do we have to write ionized completely? Okay, the idea is because they never specified is it strong or weak, right? But the idea is we know it's strong. If you put in ionized completely and then give you high concentration of hydroxide ion, okay, no issue. But if you don't put, also can because it's just 2 marks. 1 mark for the number, 1 mark for the definition. Okay, so no issue with without the completely, it's also fine. Okay, for the pH value, can I just write more than 11? Cannot. When I say predict pH, predict must have number. Okay, predict must have number. Okay, so 12, 13, or 14. Cannot say more than 12 or more than 11, cannot. Okay, I must write actual number. Okay, if no issue, moving on the next one is, we have the arrangement of atom of one material that is widely used in nanotechnology. Guys, this one we haven't learned. This is your Form 5 chapter 5. Okay, but what we have in the in Form 5 chapter 5 is nanotechnology is where we take your chemicals, we split into a very small size atoms into nano size. The size is nano size. Okay, but this one I will teach you in future but since we haven't covered it, we don't have to go through in details first. Okay, so what we can do is, okay, the first one they ask you, what is meant by nanotechnology, guys? That is a definition for nanotechnology, where you have your chemicals, your devices all in the size of nano. So what we can say is the definition, guys. This one you all haven't learned, so it's okay. So you'll just write together. Is the development of substances or gadgets using properties of nanoparticles. Means your particle very small size until nano size. Okay, so this is the definition for nanotechnology. If you cannot remember, it's fine. Okay, guys, you cannot score all definition one. Unless all the definition asked in SPM are very commonly asked like definition for nucleon number, definition for proton number, definition for rate of reaction. Then very easy lah. But like see this one, nanotechnology very rare people will actually go and memorize this. Okay, so moving down, state one characteristic of the material that allows it to be used in the production of sensor. Guys, you know what sensor? You know, like when your house got like any light sensors, okay, your door got like door sensors. So in sensors, right, they're all actually very small and they are actually sensitive. Okay, it detects movement, it detects light. So all these are sensors. So what we say is this material is highly sensitive. Or you can say high sensitivity. Highly sensitive is one. Okay, so this is one of the possible answer. But there is another answer we can say because it's so small. Because the idea of nanoparticles the theory behind is your Form 4 Chapter 7 rate of reaction. You know why? Because the smaller you can go, it means the larger surface area. So nanoparticles, every time they ask you the benefit, right, there is one general answer. We say large surface area. Okay, large surface area. So basically, because the idea of nano means I want it to be very small, then surface very big. Okay, so high sensitive and large surface area. Okay, going down, write the chemical equation for the reaction between graphene and oxygen to produce carbon dioxide. Guys, you'll be like, teacher, how I know what is graphene? If you go back up to the question, do you see they literally label graphene is carbon? So if carbon now react with oxygen, become carbon dioxide, can you write the equation? Guys, it's actually free mark. C plus O2 becomes CO2. Already balanced. 2 marks. So nice. Okay. Okay, then going down, we have a situation of landfill. Guys, landfill problem also in Form 5 Chapter 5. Okay, but we can say is it gives you a methane gas, guys. Just in case you remember Form 5 Chapter 2, we learned before methane gas. What is a methane gas? Methane gas is basically your petroleum gas. Is where we use for cooking, for burning, for starting fire. So methane gas causes fire and global warming. So what they're asking is, suggest two methods that can be done to reduce the bad impact as shown. So guys, as we say, this one, so we have organic waste decomposed producing foul odor, very smelly. Okay, so what is the problem is, how can we solve the issue of methane? Guys, since we know methane causes fire, right? Why not we take the methane, collect the methane, burn it, and we use it to generate electricity? Why not? So we can say, collect methane gas, and we use it for what? As guys, what is the term that we use in Form 3 science? There is a power station that we actually burn methane gas on. We collect food, all the organic food, it releases methane gas, and then the methane gas, we burn it and generate electricity. Yes, it's called biomass. Biomass gas. Biomass, guys, biomass means it's from organic substance that is flammable. Okay, it's a gas that comes from organic substance that is flammable, so we call it a biomass gas. And then what else? What the next problem is organic waste give you foul odor. So guys, organic waste, since it gives you bad smell, you throw it there, very wasted. So what can we do? We use organic waste in other industry, so we can convert. Since it's organic, we can say convert organic waste into something that is good for plants. Fertilizers, correct. Okay, fertilizer. Okay, so guys, this one actually it's like called environmental chemistry. Okay, that relates to environment. Okay, but it will be something very similar that we learned before in our syllabus. Like methane, you learned before in Form 5 Chapter 2. Fertilizers also we learned before in your we haven't learned before fertilizer in detail yet. Okay, so Chapter 5 Chapter 5 in future. Okay, so if this one no issue, next one is we have the setup to study the corrosion of pure metal and its alloy, guys. It's your rusting of iron nail and stainless steel nail. So guys, after 2 weeks, brown solid deposited, rusting occur. No change after 2 weeks for stainless steel, rusting is avoided. Explain the difference in observation. So guys, first thing, we write the difference in observation first. What happened is, when brown solid deposited, it means what? It means that rusting occur in the set 1, but rusting do not occur in set 2. Okay, so we can say rusting of iron nail occur in set 1, but not set 2. Okay, then what is the explanation? What is the explanation? So why iron nail rust? Why your stainless steel nail don't rust? Guys, what happened? Because iron nail is pure metal, stainless steel nail is alloy. So I said stainless steel is more electropositive. Too far away. No need to go so far. No need to go so far. Okay, so the second point is you just say iron nail is pure metal, while stainless steel nail is alloy. Okay, and we can say alloy is corrosion resistant. Okay, like this, just guys, because just 2 marks, just 2 marks, so no need to go to details. Can we write corrosion or must write rusting? Can. If you write corrosion or rusting, both acceptable. All good, all good. If no issue, let's try on the next one, question number 6. So on question number 6 there, we have sugar, and then we have compound Y is table salt. So they ask you, state the function of both compound, guys. When you got sugar and salt, guys, sugar and salt, what function? Sugar and salt. We haven't learned this in our syllabus yet because it's on your form 5 chapter 5. It's just one small topic. It's called what? Sugar is sweet. Table is salty. So what do we say? The function of it we can say as flavoring. Okay, but if you go in detail, salt and sweet, if too sweet, bacteria cannot survive. If too salty, bacteria also cannot survive. You know what do we call that? Preservative. Okay. So that's just one small question like this. But what is the type of particle for X and the empirical formula for X? So if you go back to X, you see X is this picture, right? What is the type of particle? Can it be atom? Cannot. Can it be ion? No charge. Cannot be. So the only possible answer here is molecule. Okay. But what is the empirical formula? So what you have to do first is you count all the C and H and all the O, then simplify. So how many C there? 1, 2, 3, 4, 5, 6. C6. And then how many H? So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So H12. And then O is 1, 2, 3, 4, 5, 6. O6. So C6, H12, O6. Simplify by dividing everyone by everyone divide by 6. So everyone divide by 6 will be CH2O. That is molecule. All good? No issue? Okay, next one is again calculation. Okay, but guys, since it's again calculation, so I try to go as fast as possible. They give me 1200 cm3 of chlorine gas reacted with excess sodium to form compound Y. The following chemical equation represent the reaction. So calculate the mass of compound Y produced. Technically, guys, compound Y is this guy lah, NaCl lah. And they want you to find the mass of this guy. That they give you chlorine is 1200 cm3. Any other information based on the bracket given? They give you molar mass. They gives you molar volume. So guys, with all this, I think we can start with the 1200 cm3. So with this, this is volume, and the question give me molar volume. So what is your first step? Step 1 is number of mole of chlorine is equal to volume over molar volume. Volume is 1200. Wrong. Because why? The molar volume in dm cube. Make sure you convert your cm cube to dm cube before you put in the formula. So right here is we divide 1000, we get 1.2 dm cube, divide 24. So 12, okay, 1.2 divide 24. What you supposed to get? If 12 divide 24 is 0.5, 1.2 you're supposed to get 0.05. Okay? But the number of moles now is for Cl2, right? You need to convert to NaCl because you want to find the mass of another chemical. So what's the ratio? The ratio is Cl2 ratio to NaCl. The ratio is 1 to 2. No number is 1, guys. Cl2 is no number, so it's 1 to 2. So but guys, as I said, please put unit, 1 mole to 2 mole. Then use the actual number, 0.05 mole. Your NaCl is 0.1 mole. So we say number of mole of NaCl is equal to 0.1 mole. So with this, use number of mole of NaCl to convert to mass equal to mass over molar mass. So this will be here, 0.1. What is molar mass? So it will be 23 plus 35.5. So you're supposed to get mass of NaCl is equal to 58.5 times 0.1, 5.85. Great. Okay, guys, I just quickly glance through lah. This one just normal stoichiometry, okay? No issue, no issue. Make sure it's mole, ratio, mass. Okay, so this always 3-step one, unless they give you mole already lah. Like previous question, they already give us mole, so we just do ratio onwards. Okay, so these are the ideas of stoichiometry. Move on to the next one. Okay, here comes the idea of your solid X and Y are dissolved in water. So one is sugar dissolved in water. One is your salt dissolved in water to form two solution. It shows the apparatus setup to investigate the electrical conductivity of the solution. Guys, for those who are from Selangor, this is very likely to come out in your next week Amali. Okay, so what they will do is, from the rumors I heard the chemical here is labeled as unknown. So chemical A, chemical B, chemical C, like that. So maybe they'll give you 2, maybe they'll give you 3. I don't know the details. But the idea is they're supposed to set up this thing for you, or if they ask you to set up, you're supposed to write your procedure, possible. Then what you can do is just dip your electrode into the solution and check your light bulb. If they don't use light bulb, they just use voltmeter, also can. So if the voltmeter reading actually shows you the needle deflects, then we say that the solution Y is able to conduct electricity, solution X cannot conduct electricity. Okay, right? So it's something very easy to do, but I think the hard part is maybe by writing the procedure. Okay, so we are preparing the PDF, so we will send it out as soon as it's ready lah. Okay, so if you want to check how the experiment is done, then you can go to my YouTube. Okay, I posted a reels, I think a short video about how to conduct the experiment. Very simple one. Okay, yeah. So moving on. Can you show the previous question again? This one, calculation. Okay, moving on. We have pupil K and pupil S. The first pupil say both solution X and Y can conduct electricity. So guys, do you agree with her? No. Like that, look, cannot see me. One light bulb light up, one light bulb cannot light up. See. So we can say that pupil S is more accurate because it say X cannot conduct electricity while Y can conduct electricity, which is correct. Okay, so what is the question? They say, based on your answer, which pupil gives the correct statement? So we say pupil S. Wait, is it S? S. Okay, pupil S. 1 mark. 1 mark over 3 mark. Guys, good enough. Next one. Skip. And like that. Okay, so what we say? What do we understand about this solution Y? So solution Y, he can conduct electricity. So what happened is, what is the type of particles that gives you this explanation is, so why solution X cannot conduct electricity, why solution Y can conduct electricity, we talk about the type of particles. So X is what? X is your sugar. Sugar means glucose. And glucose is what? By the diagram you see in the front, or single bond, single bond, single bond, single bond, all these are covalent bond. If covalent bond, do you have charge? No. So what is the type of particle? Is molecule. But for Y is sodium chloride, it's a salt, correct? You throw salt into water, it dissolves. So when it dissolves, it becomes Na plus and Cl minus, it conducts electricity. So what we can say about this, we say solution X contains neutral molecule and solution Y contains free moving ion. Okay, free moving ion. So that's the thing from here. So 3 marks, settle. Okay, 1 mark for the pupil, 1 mark for the solution X particles and solution Y particles. Can I just say ions? I cannot, because of the reason why salt can conduct electricity is only when it's in liquid form, only when it's dissolved in water. If solid salt cannot, solid salt got ion, but the ion in fixed position. So you cannot just say got ions. You must say free moving ion. Because if it's ion in solid state, is ion in crystal lattice structure in fixed position. So you must say free moving. As long as something that can conduct electricity, must write free moving. What if you say ion in liquid form? Free moving very hard to write, man. Free moving very hard to write, man. Wait. Okay. No need to add electrical charges. No need, just say free moving ion because just 3 marks. Okay. When the moment you say free moving ion, you get 1 mark already. Okay, all good, Okay, so moving on. Free moving ion or electron. Very good confusion for NaCl. Do you think is moving electron? No, so free moving ion. Electron, only free moving electron is inside the wire. So when they ask you why metal conduct electricity, because metal got free moving electron. Okay, so remember, if you talk about ionic compound, why conduct electricity is free moving ion. Okay, if it's metallic compound, metallic substance, metallic bond is free moving electron. So they conduct electricity in different ways. One is free moving ion, one is free moving electrons. Okay, teacher, no need to say it's covalent or ionic. No need. No need to say. Okay, unless it's like 5 marks, then you can mention the type of compound. Okay, but the main idea is the type of particle that actually involved in conducting electricity. Okay, so whenever we talk about electrical conductivity, it's either about ions or electrons. If cannot, confirm it's molecule. Okay, your neutral molecule. All good? Moving down, question number 7. We have metal R, pour into nitric acid, and then we see green solution containing ion R2+. So guys, talking about salt, hey, your favorite chapter comes into play. Salt, who is green? What salt is green? So our green salt got multiple choices. Okay, we have CuCO3, and then we have anything with Fe2+. Correct. Okay, can. So the thing is it CuCO3 or is it just Fe2+? Is here, because on the idea here is it's a green solution. If you say CuCO3, this one wrong. You know why? CuCO3 insoluble. It cannot be a solution. Okay, so the only possible green solution with ion R2+ is Fe2+. So most likely R is Fe. Okay, then moving down, oxide of Q. So Q got oxygen, but who is Q? I don't know yet. Add sulfuric acid, become blue solution containing ion Q2+. Guys, who is blue in your whole syllabus? In our whole syllabus, blue is only CuSO4. Okay, means most likely oxide of Q is CuO. Okay, all good. So the Q2+ is Cu2+. Okay, then going down, last one is solution TNO32, pour into solution NaCl, you get a white precipitate. Guys, solution plus solution, you get a precipitate. What process is this? We call this the precipitation, or in a more common word, when you pour two solutions together, you get a solid. We call it the double decomposition. Correct. Okay, so this is called double decomposition. Okay, but the issue is what? The issue is double decomposition. The rules is, what's the rules? Soluble salt plus soluble salt must form you salt partners. Get you insoluble salt with another soluble salt. Okay, that's the rules for your double decomposition. All good. Okay, so now the question is sodium chloride, NaCl, is a soluble salt. So this one no issue. Now TNO3 bracket 2. This T must be who? This T must be who? Okay, the idea is, okay, let's try to brainstorm the equation. TNO3 bracket 2 plus NaCl get you a white precipitate with another soluble salt. Okay, so now the question is, if we were to swap the partners, T here is 2+, because do you see got bracket 2? So it's supposed to combine with your, so if I were to write out the ions, so T is T2+, NO3 is minus, Na plus is Cl, Na is plus, Cl is minus. So if you can list out the ions, you swap the partners, you get T2+, Cl minus, you get TCl2. Okay, guys, I don't know who is the white precipitate first, so I remove this first. Then my Na and the NO3 combine to get you NaNO3. So guys, with the two products formed at the back, who fits insoluble, who fits soluble? Is it the TCl2 soluble or insoluble? Is it the NaNO3 soluble or insoluble? So the overall idea is got sodium. got SPA, confirmed soluble salt, right? So this guy is here. It means this TCl2 confirmed insoluble. So now you have to think backwards. Who is the ion that combines with Cl is insoluble? Who is insoluble when combined with Cl? Yeah, okay. So guys, if you remember, Cl, there are three possibilities. Cl is insoluble with the combination of Persatuan, Agama, Hindu, PB, AG, HG. So we can go with PB, yes. Okay, so I think okay, so PB, AG, HG, guys. But the thing is, guys, do you think all these three answers is possible? Some of you say teacher HG, some of you say teacher AG. Guys, but the answer must be only P. You know why? Because these three ions are PB2 plus, AG plus, HG plus. Only one ion is 2 plus, is PB2 plus. Because why? I just say T is 2 plus. So because T is 2 plus, it must be PB. You get the idea? So this means now, right now, we say T2 plus is actually PB2 plus. Is that okay? All good? All good, huh? So right now they say, did they ask any question here? No. Okay, let's go in. Salt is an ionic compound formed when an ion from an acid is replaced with a metal ion or ammonium ion. What is the ion? This is actually last time I got discussed before. This is actually a definition of salt. Okay, but they got one unknown. The definition say salt is ionic compound when an ion formed from an acid is replaced with metal ion or ammonium ion. What is the ion? So guys, all acid got what? All acid got H plus. And the H plus after replaced by metal or ammonium, he become your salt. What's the idea of it? It means, let's say example, HCl plus metal. Zinc will kick off the H, becomes the NCl2 and H2, right? This is a salt. So do you see the trend is acid H replaced by zinc become zinc chloride salt. Okay now, so who is the ion that got replaced to form salt? Is hydrogen ion. Okay, can I write the formula of the green solution in set 1? So green solution is who? The Fe2 plus, right? But we add nitric acid, guys. What is nitric acid? Nitric acid is HNO3. So the equation is Fe plus HNO3. Fe take the NO3, become what? Becomes FeNO3 bracket 2. Okay, hopefully then can Fe2 plus NO3 minus. Better. Based on the observation in diagram 7.1, identify ion R2 plus, S2 plus, and ion T. Okay, there's no S2 plus. It's just Q2 plus. Okay, they corrected the question. Okay, see, even trial paper got mistake. Okay, don't worry. Yeah, so R2 plus is who? Is Fe2 plus. And then the blue solution Q2 plus, Cu2 plus. The ion T that we finally want is Pb2 plus. Okay. Can we write Fe? You mean just Fe? No 2 plus? Cannot write the whole thing. Because identify ion. So write the full ion formula, full ion symbol. I thought need to maintain SR. Oh, you mean this one? You mean the chemical formula for this? Oh, okay, this one. Means this one you say RNO3 bracket 2. Yeah. Can also. Okay, but the answer marking scheme is FeNO3 bracket 2 lah. Okay, so maintain as R also can. Maintain as R also can. Teacher, can you go to set 3? Set 3, this one. Yes. Any issue? Any question before I move on? No. Okay, you want a screenshot? Okay, so okay, moving down. Write an ionic equation and calculate mass. Guys, let's write ionic equation. We have your ion T react with chloride ion to form the precipitate. So guys, what is ion T? T2 plus. Chloride ion is who? Cl minus. So plus Cl minus, you form TCl2. That balance equation. Okay? And if ion T is 0.1, what is the mass of the precipitate form? So I need to convert the mole to TCl2 first. But what is the ratio? That's the ratio. No number to no number. So what we can do? T2 plus ratio to TCl2. The ratio is 1 mole to 1 mole. Then 0.1 mole get you 0.1 mole also. So the number of mole of TCl2 is equal to also 0.1 mole. So with this, let's find mass. The number of mole of TCl2 equivalent to mass over molar mass, which is I bring my number of mole 0.1. What is my molar mass? Given by the question, 278. So I supposed to have mass of TCl2 equals to 27.8 gram. Guys, do you realize in one paper, you got 3 stoichiometric calculations. So please, guys, do not give up stoichiometry. Stoichiometry must do. Every past year, every exam question, every papers you see, confirm got at least 2 to 3 stoichiometry. Okay. Teacher, when we write ionic equation, must it be in terms of T or PV? Okay, so here they say ion T, right? So we keep it as ion T. Okay. They keep it, this is, they mention ion T, we mean as T2 plus. Is there any mark for doing ratio? Yes, guys, ratio 1 mark. Final 1 mark. Ionic equation 1 mark. Okay. Can ionic equation 1 mark. Okay, so guys, no issue for this. Next one, you see a big factory. They say a type of acidic gas Y released by the industrial factory. Gas Y can be produced from the reaction between sodium sulfide, Na2SO3, and hydrochloric acid. Draw a label diagram to set up to verify the presence of gas Y. Guys, first of all, do you even know what is gas Y? It's formed from Na2SO3 and hydrochloric acid. So guys, what do you think is the gas forming on? Someone asked, teacher, do I have extra latihan for stoichiometry? Yes, my YouTube channel, I got one specific video just to do stoichiometry. And I think, if not mistaken, I remember I attached a PDF below in the video. The PDF, the video there will be actually, there's a PDF to actually do more questions about stoichiometry. So you try to find the video in my YouTube channel. Okay. Okay, sulfur? No. Guys, for Na2SO3, is hydrogen gas? No. Guys, this is a this topic, this is a reaction that a lot of people never study and revise. It's actually sulfur dioxide. Okay. Okay, the equation goes in this way. I mean, because they never ask for equation, but I give you the idea. Okay. So the idea is Na2SO3 plus HCl. So by right lane, the ions that is Na plus, SO3 2 minus, H plus and Cl minus, right? So by right, you swap partners of Na and Cl, you get NaCl. Okay. But then the H2 plus and the S2O3, SO3 2 minus, they supposed to combine become H2SO3. But guys, if you remember, H don't like to take all the stuff on. H only like to take one oxygen. He like to take one O. So the H2SO3 will break up into H2O and SO2. So guys, this is the gas Y that you are forming. So if you want to test gas Y, you need a specific setup to test gas Y. You know what is the specific test to test gas Y? The sulfur dioxide. For those who forgot your gas test for sulfur dioxide, is supposed to use your oxidizing agent. Something, as I said, guys, this one, as I said, a lot of people never revise this. It's actually in our book. Guys, let me show you, just in case you forgot where we see all these things. In your midterm seminar, if not mistaken, your midterm seminar, I think got the notes inside. Remember the gas test? The gas test here, gas test, all the gas tests here, you see, sulfur dioxide is literally written here, Na2SO3 with hydrochloric acid. You have the gas release tested with acidified potassium manganate 7 solution, and it will decolorize the purple color. You see, the part where we highlight everything, this part never highlight, because guys, this one very low chance, very low chance. So if come out this, it's okay. But never mind, since now you all learn already, you all know what to do lah. Okay, now so means the 2 marks here is you draw this out. Okay, the 2 marks here is you actually have to draw this out into here. This. Okay, can. So guys, if don't remember, it's okay, guys. 2 marks. Let it go. Let it go. Okay. Must it be slanted? Yes, must be slanted. Okay, must be slanted. If not, you'll pour out. If not slanted, everything will pour out. Okay, good. All good, huh? Okay, now guys, start to go for essay. Need to label apparatus. Draw a label apparatus setup. Yes, guys. Label. You try lah, guys. You try your best to label because it's 2 marks, right? They label the chemical already. The apparatus usually no need one because label diagram is to label chemical. Usually label chemical. Okay. But if you scan, you just label everything lah. Like this one is like test tube. Okay. So then this one is delivery tube. Okay, just in case you need to label this. What if I miss out labeling one apparatus? Well, lose mark? No. Usually labeling apparatus no one. It's labeling the chemicals that gives you marks. Okay, it means if you miss out, like say HCl, then you lose 1 mark. Okay. Yeah. Okay, guys, let's go. Question 8 is not essay yet. It's 9, 10, 11. Okay, it's not essay yet. Come. So we have your what is represented by 1/time. Guys, this is called the reaction as the rate of reaction determined by recording the time taken for the blue color to appear. So who is blue color? Is the product iodine and water. I think the blue color is this guy lah. Okay, because it's tested with what? Iodine reacted with starch to produce dark blue solution. Very bio. Okay. So with this bio idea, so now you see blue color, you know the reaction is actually giving you iodine. So the test is when I increase concentration of potassium iodide, the time taken is shorter. So why? Because higher concentration, the higher rate of reaction, then shorter time taken. Okay, now so that's what we know in the rate of reaction. What is represented by 1/time? Guys, for those who actually go through my booster class, I mentioned already. Whenever you see 1/time is rate of reaction. So answer here, rate of reaction. Teacher, will you upload this to YouTube? Yes, I'm streaming to YouTube actually. So after the class finished, technically it will be on YouTube. Oh, yeah, YouTube got 3%. I don't know who's that three random person, but YouTube got 3%. Okay, so now sketch the graph for concentration of potassium against 1/time. So concentration higher, 1/time also higher. So the graph is directly proportional. So the graph goes in this way. Concentration. Must label everything of potassium iodide solution in what unit? In mole dm -3. Then against 1/time. No unit. Is that unit? Got S minus 1. So S minus 1. So it's just a sketch. So therefore we go with they never start from 0, right? Because it's just 3.0 and then 0.05. So I start from halfway lah. So probably like this. Okay. 刚刚很努力在 YouTube 看了半个小时，过后想起来为什么不进 Zoom？ So you went to YouTube, but now you come to Zoom. Why? You are lagging a lot. Oh no. Do we lose mark if you don't use ruler? Yes, because directly proportional graph must use ruler. Can I just write concentration without a chemical? Cannot. Must write concentration of the whole thing. The chemical must be labeled on the axis. Use pencil. Yes, use pencil. Okay, use pencil. Okay, so 差不多要倒了. Guys, it's only 1 a.m. in the morning. Guys, you know what happened? I still got friends at my house. They still playing at the bottom. I think they're playing mahjong. I can hear them screaming at the bottom. So later on, after I finish this class, I will join them with mahjong. I so kesian. Yeah lah, guys. You see, they enjoy life, and I'm here teaching you all chemistry. You all don't fall asleep, I slap you. Yeah. Okay. 够力, I guess, but your bio 老师 is there also. Guys, your bio teacher is here. Later she got something to say to you. Okay. For those who want who got take bio, later she come. Okay. Your physics teacher also here. Yeah. Okay. How are you able to do this? This is the young is still night. Teacher, for question A isn't supposed to base on table 8. For question A based on table 8. I mean, No, they never say anything. They say what is actually 1 over time. 1 over time means that when you take your 1 divide time, okay, because the reason the thing is there is no measurement inside here. If you remember, if you want to calculate rate of reaction, right, you can do volume over time or mass over time. Okay, now so with all the measurement given, then you can do mass over time or volume over time. But if like this experiment, there is no measurement, you are just looking at colors. So no measurement, you do 1 over time. Okay, now so what exactly is 1 over time? Is the simpler version of rate of reaction when you don't have mass, when you don't have volume. Okay, now so anytime you see 1 over time, is rate of reaction. Okay. Call Wei En 来上课。Jiahern, Wei En, Wai Ling. Guys, you all guess lah. Later, who come later you all see. Jiahern not here. Sorry. Sure, is the night is still here? No. At this time, I must say, is the young is still night. It's time to see World Cup, guys. Yeah, World Cup start already in Netherlands. I want to support Netherlands. U10 is here. No, U10 is not here. U10, the old man already. He sleep already. Okay. Support Argentina. Here today, no Argentina. Okay, now next one. State the factor that affect rate of reaction in this experiment. So guys, if you hear, you say, teacher, okay, I know. Concentration. You write concentration. Congratulations. No mark. Why no mark? Because not detailed enough. You must write concentration of potassium iodide solution. Guys, I warn you, in your next coming exam, don't be lazy. Okay, must write every detail as possible. Okay. Now, going down, compare rate of reaction for set 1 and set 2. Explain your answer based on collision theory. This is also the place where you all lose all the marks. You say, teacher, collision theory, I know, but you all still get 0 mark because you all never write a lot of stuff. What are the stuff that you all never write? Example, rate of reaction for set 1, set 2. We say set 2 is faster than set 1. Right? So we say rate of reaction of set 2 is, guys, to save you some time, let me put in short form. So rate of reaction of set 2 is higher than set 1. Okay, why? Because got higher concentration, cannot. So we can say that concentration, guys, if you say concentration is higher, no mark. That's it. Concentration of what? Guys, if you hear you say concentration of, must say the chemical name of potassium iodide solution in set 2 is higher than set 1. Okay, higher than set 1. Okay, then what's the next keyword, guys? Since it's only 3 marks, right? There are some part that you can skip, but I don't want to skip. I write all the answer. I write in full marks, full essay. Okay, so what's the next keyword after concentration? Is the number of particles per unit volume is higher in set 2. But the problem is 1 particle. What is the focusing particle? You follow the ionic equation. Do you realize in potassium iodide, only the iodide is involved in ionic equation? Is potassium even here? No, right? So it's about the number of I minus is more in your in this whole reaction. So we say that number of iodide ion per unit volume in set 2 is higher than set 1. Okay, then last 2 sentences is what? FOC and FOEC. So what is FOC? Frequency of collision. What is FOEC? Frequency of effective collision. But guys, if you write these 2 things, no mark again. You must say frequency of collision between who and who. So focus on the ionic equation is between all the ions here. So it's the collision between H2O2, I minus, and H plus. So therefore, we can say that is frequency of collision between H2O2, I minus, and H plus in set 2 is higher than set 1. Then finally, FOEC between the same particles, H2O2, I minus, and H plus in set 2 is higher than set 1. Okay, so hopefully this full essay answer, when they come out 5 marks, you can use the same idea lah. Okay guys, all good, all good. So if no issue, this is a cup of hot water with a lump of sugar without changing temperature. State a method to dissolve the sugar faster at a higher rate of solubility and explain your answer. So it's a lump, means big size. How can you make it smaller? Crush the sugar. Yes, so we can say crush or crush the sugar. That is that's the first mark. But when you explain why crush the sugar, you can say the size of sugar becomes smaller than total surface area of small size sugar exposed to water is larger. Okay, which factor is only FOEC? Catalyst. Okay, only catalyst. Catalyst is the only factor that don't have FOC, just FOEC. Okay, teacher, can we write KI or must we write full name? Actually, you can write KI. You can write KI. You can write concentration of KI in set 2. But guys, as I said, don't lazy. Don't lazy. Okay, so all good, guys, finally enter essay, guys. We use 1 hour and 20 minutes to enter essay. Okay, what if you never write small size sugar? Okay, it's fine. You say total surface area of sugar exposed to water is larger. Okay, the small size sugar is just extra elaboration. Okay, so guys, are you ready? Guys, essay lay, I'm not gonna write the whole thing because confirm not enough space. There's no paper provided here. So got space here. But never mind, I will try to write every point that gives you marks. Okay. So the first question is 2 examples of unsaturated hydrocarbon compound, X and Y. But guys, if you look at this, double bond and triple bond got 5 carbon. Can you name me these 2 things first? What do you call a carbon compound with 5 carbon? Start with what prefix? It's alkene. Okay, I know alkene, but what prefix? We have meet, eat, prop, wood. So 5 carbon is pent. Correct. Pen, P-E-N-T. So it's pentene. Okay, very good. It's an alkene, so pentene. Okay, but very good. Not bad, not bad. A lot of people say, okay, my ex-pretty beach. Not bad, remember this, So specifically, pentene supposedly is pentoene. Why pentoene? Because your double bond falls between carbon number 2 and carbon number 3. I take the smaller number. Not butt, man. My ex-pretty butt. Okay, guys. I like pretty beach also can. Hey, okay. Now, that one depends on your ex. Do you guys break up peacefully? No, correct, man. If you break up peacefully, pretty butt. Okay, you break up not peacefully, pretty beach. Okay. So, okay, so on the right hand side, what is this? This is also pent, but pen what? It's a triple bond. Pentyne, correct? Y and E. But guys, I will still call this a pentoine. Hey, very funny name, right? But yes, it's correct. So what they want is state 1 characteristic of unsaturated hydrocarbon. So guys, what is the special thing that we know about unsaturated? Got double bond or triple bond. Yeah. Okay, but guys, cannot just write double bond, triple bond. You must say contain double or triple. Guys, choose one. Bonds between carbon atoms. Okay, if you never write between carbon atoms, you don't get the 1 mark. Therefore, on this, then on the other hand, we have your name. Okay, guys, we have the name already. Yay! So X is pentoene and Y is pentoine. Okay, then draw the structural formula for another isomer of compound Y. So guys, compound Y, can you draw me another isomer? Isomer means what? Guys, just in case I ask you, what is the definition of isomer? we say same molecular formula, different structural formula. Okay, same molecular formula, different. Sorry, that is why I bracket the wrong one. So basically what they are asking you is this is called isomer. Okay, isomer is same molecular formula, different structural formula. So that's the definition. Okay, so what is the different drawing, guys? Since they can have pen 2 ion, I can have pen 1 ion. Okay, so my drawing for here is 1, 2, 3, 4, 5. But I can put my triple bond on the most right or on the most left, up to you. Okay, and every carbon must have 4 bonds, guys. Every carbon is 4 bond, not 4H. Okay, so okay, every carbon is 4 bond. Okay, this one don't have. Sorry, too much. Okay, like this. So this is the drawing. So this is called pen 1 ion. Okay, all good, all good. Okay, so guys, if no issue, okay, all good. Okay, next one. It shows the experiment that shows you sootiness of flame during the combustion of both compounds. So I have filter paper 1 and filter paper 2. Okay, after they burn, filter paper 2 give you more black soot on the top. Okay, so now they say, right, chemical equation for combustion of compound Z. What is Z? Let's see. They say Z is a saturated hydrocarbon Z that has the same number of carbon atoms as compound X. So got C5. And it's a saturated, guys. Your whole syllabus only got one saturated thingy. It's alkane, correct? So alkane, what general formula? CnH2n plus 2. So if we C5, it comes with H12. Okay now. Can so your Z is supposed to be C5H12. And if you were to write combustion equation, C5H12 plus what? Combustion required oxygen. Then what is the fixed product for complete combustion? CO2 and H2O. Then balance equation, you're supposed to get. See, I put 5 here first. 5 and then got 12H. So this one times 6. So times 5 times 6, what do you get? You get 10 oxygen, 6 oxygen, in total 16 oxygen. So here I oxygen on the left times 8. Okay. Which filter paper shows the sootiness of compound Z? Explain your answer. So guys, which one do you think is Z? Saturated. So if you compare, right now, we are burning to this idea here, right? So Z now become alkene already. So when it become alkane, alkane is supposed to give you more soot or less soot. By logical concept, less soot. Why? Because alkane got more H, right? More H means lesser carbon percentage, then lesser soot. Correct or not? But do you think like that can give you like all the marks? Cannot ma. So technically, you still need to show your working. You have to show your working where you have your let's say we say this one for compound X. What can we do is we calculate the percentage of carbon. Okay, so we have calculated percentage of carbon. Compound X is C5 over C5H10 multiply 100. While for compound Z is C5 over C5H12 multiply 100. So guys, the only difference is what? The H for X is 10. The H for Z is 12. So if you do the maths, you get percentage, So when you get this percentage, guys, by right, your X alkene, alkene should be higher percentage. Alkane is lower percentage. So the answer is filter paper 1. Filter paper 1. Supposed to give you less soot. Z supposed to give you less soot. Okay? But why? We say percentage of carbon by mass of compound Z is lower than compound X. So in 6 marks, guys, where's your 6 marks? So 1 mark for calculation, 1 mark calculation, okay, 1 mark for filter paper, and then 1 mark for this, then 2 mark for equation. Okay, all good? Can guys, I lazy to count you're supposed to count it, you all can count it yourself, okay? Very simple one. Just make sure you get higher percentage for X, lower percentage for Z. Okay, higher and lower. Okay. Move on. Okay, moving on, we have a table that shows you compound J, M, and Q, also carbon compound. So relate to about alkane, alcohol, alkyne, carboxylic acid, ester. So J is formed from fermentation process of pineapple chunks, guys. When you learn fermentation, after fermentation, what is the only product form that we learn in carbon compound? Fermentation always give you what? Fermentation, after you ferment your sugar, ferment your glucose, you always get alcohol and carbon dioxide. So alcohol and carbon dioxide, which one most likely to can burn and give you blue flame? Alcohol. And who is the specific alcohol for fermentation? Confirm is ethanol. Fermentation only form one alcohol is ethanol. Okay. Then compound M is compound that has double bond between carbon atom. Hey guys, hey, carbon atom double bond is alkene. Kind of. But which alkene is this? It's the second member of homologous series. What is second member? Means who's the first member in alkene? Think about alkene. Is your first member methene? This is trying to test you. Why? Because guys, can you have one carbon and double bond? Cannot. So first member of ethene, of your alkene, supposedly is ethene. So what is the second member after ethene? Technically is propene. Okay? And what is Q? A non-hydrocarbon, guys. Non-hydrocarbon means cannot be alkane, alkyne anymore. It's either alcohol, carboxylic acid, or ester with 3 carbon atoms, and it reacts with J to form sweet and fruity smell. Guys, we know this is ester, but guys, it's your Q ester. Read properly. He reacts with J to form ester. So how do we form ester? Ester is alcohol plus carboxylic acid, you form ester. So since J is the alcohol, means your Q is your carboxylic acid. And what do you call a 3-carbon carboxylic acid? A 3-carbon carboxylic acid is what? Propanoic acid. All good? Okay, so right now they say identify J and Q. We've done this already. Done. 3 marks. And state the general formula. Draw the structural formula. 9 marks. Wow, guys. Very happy. Okay, what is the general formula for ethanol? For alcohol? CnH2n plus 1 OH. Propene for alkene? CnH2. For propanoic acid? CnH2n plus 1 COOH. Guys, like this, 6 marks already. Happy, right? Like this, 6 marks already. Okay. How to know M is propene? Okay. Second member. First member of alkene is ethene. Second member is the next one, 3 carbon, propene. Okay, because first member, because you all always thought first member is 1 carbon, right? This is to test you whether you know alkene don't have first member. I mean, don't have 1C as first member. So his first member is actually 2C. You get it? Okay, first member is ethene, 2C. Second member is 3C, propene. Okay, because don't have methane. No such thing as methane. Okay, and they want to draw all these 3 out. So guys, how do you draw ethanol? Ethanol is 1, 2, C2, H5, OH. How do you draw propene? 1, 2, 3 with a double bond. Okay, how do you draw propanoic acid? Again, 3C, 1, 2, 3, but one of the C got COOH, and the rest is C2H5. So guys, do you see these 9 marks? Easy. Hey, you literally can score these 9 marks using less than half of your test pad. Less than half of your test pad page. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, so interesting. Okay, so happy. All good, guys? All good, Okay, moving down, Okay, now compound J can also react with acidified potassium dichromate 6 solution. State the name of the product of the reaction. So guys, what is that? So what is happening here is compound J is who? Compound J is ethanol. So if ethanol reacted with acidified potassium dichromate, this is called oxidizing agent. It means it undergoes, compound J will undergo oxidation. So if compound J, alcohol undergo oxidation, alcohol oxidized becomes the next topic called your ethanol becomes ethanoic acid. Okay? So the idea is alcohol become carboxylic acid is undergo oxidation. So now it's ethanol becomes ethanoic acid. Okay, so if there's no issue, basically at here, we have your guys, your physics teacher is here.
Hey, this one very hard to. Very hard anyway. Cannot understand eh. 哦，我现在这么你开这样多个 screen 的喂。哦，你做 live 啊？
在 YouTube
哇，真开心啊喂。
嗨，老师。
Hello。会师 ，Hello。
嗨，同学。
Why not?
Why not?
Wait.
You wait. That's not your physics teacher. You wait. I see, guys. You call Wai-Ling. 哎呦，早上才见，今天又见。哎呦 ，OK, not your physics teacher also, guys. Come in. Guys, he's here. 来看这里。
Everyone. Hey, who is that? What you want?
我在 share 这不要的 screen。
Everyone, watch the video
28个
啦。
人神经病啊，28个人。
Watch the damn video 啦。
call Wai-Ling 来。
Hi! Hey, remember to watch the YouTube video, guys. I posted the video already. Please go and watch,
Watch
okay?
teacher Jiahern.
Hey, no, before that, no, wait. You physics first one. You study for physics first.
是啊 physics first day 嘞。
If it's chemistry guided, physics guided, bio should be unguided. Should be lah, hopefully lah, okay? But I think bio is unguided.
为什么
Why sit in the night? No lah.
Elise?
I go dinner.
Why Elise is here? 哇，很
多
乱啊喂。
很乱。
Physics hard.
那也会汗咩？
不会，很容易。
Bio so hard. Why is it hard? Bio is not hard.
来了。
Why is it difficult? Bio is not difficult. It's very easy.
Yeah, watch the video. Watch teacher Jiahern's video.
Okay, so now I'm gonna take over and then we're gonna start teaching physics already.
Okay,
然后 share 那个 link。
Bio? Start teaching bio?
用那个直接那个 iPad 换就可以了。
Chemistry easier than bio.
How is it possible? Guys, bio experiment so easy this time.
Bio easier. What is bio?
哎呦，唔對咗試下。
TTC teacher Roja.
You all go watch the YouTube video or not that posted? You all watch already or not? Watch already or you all steady already?
No lah, they busy with chemistry.
我寫方方式也不會。
我這樣不行。
Watch already 啊？
旁邊收嘛，加好一點。
对啦，already 有 noise cancellation 的啦。
Watch already.
Same time teacher. 到底？哇，你真是
那個是這個是
有人講公費嘛，就會。
公費嘛就。
不被嘛就
為什麼？
你跟他們講。
digestion of carbohydrate.
講。
Teacher still have 12 of extra class.
Better wake up
Got 88 human here. Why you all
這個是什
so
麼？
他自己的 auto caption.
哦，它不準的。
對吧？不能去那裡
When are you guys sleeping? Everyone else sleep already.
Yeah,
It's getting
wait,
lesser.
you're preparing your material for you now.
I'm so kimia.
Aya, kimia easy 而已嘛。
妈呀，他们恐
Takes
怕，
time 的。
哇，这个看到头痛哦，这个搞笑。
The night is still young.
Wow,
Then
is
you
still
guys like
night.
2 a.m. guys.
还讲了吗？
The young is still night. The young is still night. It's 2 a.m. guys. It's 2 a.m. What are you guys doing here? Maybe some already sleep, but you're still in the Zoom. It's really 2 a.m. Why you share extra class? 30 minutes you tell me very long. Now you will tell me
应该是被骂的，是吧？
need to log in teacher. Usually I extra class.
燕如会骂的，
哦
所以燕如很多人都念。
I'm
I'm glad I didn't sleep. Jiahern study no talk.
Very good for
You should be continuing in oxygen lab. 老师 we stay before 12 a.m.
哇
Yes. Lucky you attend.
你这就开这么看 ，scream 了。
我差不多，我跟你讲。
好像
Teacher, I'm your biggest fan. I'm your biggest fan.
哎
Faster.
跟
是吗？谁的？
看不到你，
拉面啊
那个 screen，那个 screen，
那个，
这个看不到你。
哎，看到他头红色。
对啊，hello。I told you already why when you said gone just now I went dinner.
Dinner。
Damn. 2 hours just now physics, now was 2 hours chemistry.
Why no invite me?
哦，
没有，
刚才你这个
I want
没有啊，
free.
你早上是呢。
哦，不是，所以可以。
just now.
After dinner, teacher play mahjong. Who?
另外一个。
Hey, you all finish already or not? Want to
Shall we-
keep chemistry? Finish already. Class finish already or not?
没有啊。
Hey, people haven't finished class yet.
Sorry。
Not yet.
Good luck for exam, guys. Good luck.
Finish 了啊，你看这个 finish 了。
Hey, Rojan, naughty Watch the video. Watch the video. Good luck for exam, okay? 可以跟你也可以吗？很多个你吗？
这个不能了，
有坑，
这个不能，
不能。
不能了，就是。
Teacher looks so 无奈，不无奈。
乱了。
关键问题现在才问 ，What is the 关键问题？现在才问，Sorry guys，
上完课了没有？
还没有。
你们玩了吗？哦，你们要走啊？chaotic ending. The big three, 三大理科老师都在。喂 they you see guys, they stop mahjong already. They say they lose a lot. Hi. Guys, the young is still night. Okay, guys, let's finish off this. Hey, guys, we finished question 9 already. Come, question 10 and 11. Teacher, I know join. I want to join, but they finished already. Okay, skip 10. Why? Because 10 too easy. Okay, can we finish by 2? I want to sleep. Guys, 20 minutes. Let me speed run through 2 essays. Let's try. Okay, question 10 show you the relationship between the concentration of acid and pH value for acid A and acid E. So both acid are monoprotic acid, but by the idea here is, see, concentration higher. Okay, because you see going to the right, it's getting lesser concentration. Okay, so technically is lower concentration, higher pH value. Higher concentration, lower pH value. But the thing is, no matter which one higher or lower, you realize the acid A is always basically lower than acid E. So guys, A always lower than E. So what is A? What is E? Okay, basically A is strong acid. And then E is weak acid. Okay now, because based on pH, no matter what kind of concentration, strong acid always lower than lower pH than weak acid. Okay, so going down is we have these 3 experiments. So 1 and 2, 1, 2, 3. Okay, so 1, 2, 3 we have heat of neutralization and negative 57.3 kilojoule per mole. Okay, but then we have your negative X and negative Y. Okay, so with the negative X and negative Y line, we don't know the idea here is we have your sodium hydroxide with acid A, which is strong acid. Wait, let me double check. A is strong acid. A is strong acid. Okay, so A is strong acid. Okay, strong acid. E will be weak acid. But for number 3, it's not changing E. It go and change the alkaline, become weak alkaline. Okay, now. So with the idea here is, if you have sodium hydroxide is strong alkaline, so strong gives you the maximum heat of neutralization. But if one of it become weak or both of them is weak, that's going to give you a lower heat of neutralization. So usually it's like -52. This one is like -50. Okay, estimated, guys. Estimated. So state 2 information of exothermic. Guys, what do we know about exothermic? Number 1, heat release. Number 2, what else? Your surrounding temperature become what? Surrounding temperature increase. Surrounding temperature increase. So 2 marks already. Then now, suggest acid A and acid E. Guys, give me. Can we just write heat release? Yeah, heat release is literally 1 mark. Or if you want, you say heat release to surrounding. And surrounding temperature increase. Because guys, I going in point already. I going in point form. Let's go slightly faster. I aim 2 AM a bit hard. Okay, so what is A? What is E? I know A and E must be strong acid and weak acid. But guys, what is the trick is they must be monoprotic. Cannot give me sulfuric, cannot give me what else? Cannot give me sulfuric acid, cannot give me monoprotic acid. So who is a monoprotic strong acid? So monoprotic strong, it will be HCl or HM3. Monoprotic weak acid only got 1. Ethanoic acid, CH3COH. Okay, so you can write the name, you can write the symbol. So just suggest okay, you can write the symbol, you can write the name. Write the chemical equation for the reaction in set 1. So set 1 is your now we know your acid A is, let's say you say A is hydrofluoric acid. So it's hydrofluoric acid plus sodium hydroxide. You swap your partner, you get NaCl plus H2O. Okay, settled. Can calculate temperature change. Guys, what is temperature change in our calculation? So for heat of reaction, we have 3 formulas. Your number of mole, Q, and delta H. So Q is MC theta. Delta H is Q divide number of mole, and number of mole usually is MV over 1000. So how do you find temperature change, and which one is temperature change? Is to find your theta. Okay, now, so how you find your theta? First thing, you need Q. But how to find Q? You need delta H. Do you have delta H? Yes, the question gave me -57.3 kilojoule per mole. But guys, remember, negative do not involve in your calculation. The negative is to show you it's exothermic. So when you do calculation is, we can go with the idea, your delta H equals to Q over number of mole. But guys, before we do this, we do not have number of mole, so therefore we have to find number of mole first. What is number of mole? We have 50 cm cube, 50 cm cube. And is there any concentration? They give you concentration of the sodium hydroxide is 1.0. So it's given by the question. So we can do calculation for sodium hydroxide, NaOH. We can do MV over 1000. So M is 1, V is 50, divide 1000, you get 0.05 mole. Once you have number of mole, I substitute next one. Here becomes 0.05. Delta H is 57.3 kilojoule per mole, but make sure you convert to joule. So you multiply 1000, so it's 57,300. And then what you do to find your Q? So what we do is Q equals to 57,300 times 0.05. You're supposed to get let me brainstorm. You're supposed to get 2865 joule. Then once you have your Q, then we do Q equals to MC theta. Then your Q 2865. Your M, right? What is M? And MC theta, the M is actually volume. So what is the total volume? Is 50 cm cube acid add into 50 cm cube alkaline. So this M is total volume in MC theta. So it's 50 plus 50. So it's 100. So it's 2865 equals to 100. And the C is your specific heat capacity. It's always 4.2. And then theta. So theta eventually is 2865 divided 420. Okay. So the final answer here should be 6.8 degrees Celsius. Okay, so something like this. So if you were to actually calculate temperature, you're supposed to go with this way. Okay, calculate number of mole, calculate Q, and then use your Q to calculate theta. Okay, is that no issue? Next one is, what is the compare pH value for both acid A and E with a concentration of 0.01? So if you go to the graph again, 0.01 in the middle, pH is here and here. So who got higher, who got lower? So we can say your strong acid is always the lower one. So what they say is Explain your answer according to the following aspect of concentration of hydrogen ion. Okay, so the first mark we say, okay, what do we say is the first mark is no. Compare pH value for both acid A and E with a concentration of 0.01 mole or with the pH value of 1.0. Determine concentration when pH for A with a pH of 1.0. Okay, so now what we say, so if you go to pH 1.0, if pH 1.0, your concentration is 0.1. Okay, now, so that is the first mark that the question 1 is. Based on pH 1, what is the concentration? So 0.1. So our first mark here is concentration 0.1 mole dm negative 3. Okay, and then compare already, you say the concentration of hydrogen ion. So we say based on the pH value, we say pH value of acid A is lower than acid E. Okay, then explain in terms of concentration of hydrogen ion. So we say A got more, okay, A supposedly we now have your, okay, because one is strong, one is weak. So if it's strong, strong always give you more H plus, right? So we say concentration of acid A, okay, of hydrogen ion of acid A is higher than acid E. Then the relationship between concentration and hydrogen ion and pH value. So concentration is the higher, guys, a bit lazy, the higher the concentration of H plus, the lower the pH value. Okay, there's no issue. And next one, explain the difference of heat of neutralization of set 1 and set 2. So guys, if you remember, set 1, set 2 is about the weak acid and the weak alkaline, right? So in set 1, set 2, set 1, set 2 is comparing on what? Set 1, set 2 is change from strong acid to weak acid. So this one here, from set 1 to set 2, you say strong acid to weak acid. Okay, but set 2 and set 3 is what? Set 2 and set 3 is you remain acid E, weak acid, no change. You change strong alkaline to weak alkaline. Okay, so this one here is strong alkaline to weak alkaline. Okay, so with this, what do we say in 7 marks? So they say predict the value of X and Y. So for X is only strong acid, right? So X can be negative 52.0 kilojoule per mole. Guys, put any random number that's less than 57.3. Then your Y must be much, will be even lower than negative 50.2. Let's say negative 50.2 kilojoule per mole. Just now was 52, now 50.2. Guys, any random number, as long lower than 57.3 for X, then Y must be lower than X. Okay, so that's the trend that you can see from here. So 2 marks for this. The rest is to explain your weak acid, weak alkaline. But when you mention weak acid, when you mention weak alkaline, you technically get the definition, you actually get the marks already. But what is the last keyword? Okay, guys, because weak acid is what? I believe you all remember, ionized partially in water to produce low concentration of H plus. For alkaline is produce low concentration of OH minus. But what is the last sentence that you all always forget? Whenever you have your weak acid, weak alkaline, the last sentence is sum of heat energy absorbed. Sorry, it's exothermic, heat energy release is absorbed to fully ionize the weak acid or alkaline in water. Okay, so this is a very important keyword. Whenever they talk about weak acid or weak alkaline, you're going to use this keyword. Okay, as the last sentence, guys, as the last sentence. Okay, before that is the marks comes from the prediction of value, 2 marks for X and Y. And then got 4 marks is the definition for weak acid and weak alkaline. Okay, you say ionized partially in water, ionized completely in water, ionized partially in water, all this, you get 4 marks to define the strong acid, weak acid. And the last mark is this. Whenever you have weak acid or weak alkaline, you have 1 sentence as this. So 7 marks. All good? So if you have no issue, let's look at question number 11, guys. Last question in here. Okay, basically last question is we have your why meow meow haven't sleep? Okay, a lot of people want to leave first. Okay. If you cannot tahan, then leave first. I'm gonna give you one last point, okay? Meow meow haven't sleep because I'm still talking. Okay, so based on the idea here is, okay, so now what we can do is we have your half cell equation, but it's actually not arranged correctly. Guys, if you remember, the table supposedly arranged in from the more negative value to the more positive value. Okay, it means that mg, this one is supposedly is the higher one. Okay, so we're supposed to go with mg 2 plus 2e mg, this one negative 2.38, then followed by, guys, I'm rearranging the table. So next time in exam, when you see the table is not arranged in the correct sequence, must rearrange first, okay? Then followed by Cu2 plus 2e becomes Cu, positive 0.34, and then O2 plus H2O plus 4e becomes 4OH, is positive 0.40. Okay, so this will be the correct arrangement. Okay, so with this, okay, with the idea here is this is a cell notation represented by the chemical cell, which is right now got magnesium and copper involved. Okay, so it's like magnesium losing electron to copper. So the idea is magnesium lose electron to form Mg2 plus, and the electron will flow to the copper 2 plus, and copper 2 plus will gain electron, become copper. So the flow of cell notation is going this way. Mg lose electron. Okay, so Mg2 plus, Mg to Mg2 plus is lose electron. No? Then the electron go to the Cu2 plus, you gain the electron into Cu. So that is the idea of cell notation. So now state the energy change in chemical cell. So guys, we are using chemical to generate flow of electron. And what is flow of electron? Flow of electricity. Okay, so now we can say this chemical energy to electrical energy. Chemical energy to don't do arrow, guys. Must say to electrical energy. Okay, when doing cell notation, is it compulsory to write the physical state? Okay, if the equation give physical state, you write physical state. If the equation never give physical state, it's okay to not write. Okay, you get the idea? So means you follow the table, you follow the question. If got, just copy. If never give, just leave it. Don't need to write. Identify negative terminal of the cell and give one reason. Draw the apparatus setup and calculate the cell voltage. So what we can say is, who is the negative terminal? Always based on the more negative inert value. So magnesium and copper. One is negative 2.38. One is positive 0.34. So who is more negative? Magnesium. So the answer here is magnesium. 1 mark. Magnesium. Okay, but they also ask you and give one reason why, because you can say magnesium is okay, we can say magnesium has more negative inert value than copper. Okay, then with this more negative inert value, then they say ask you to draw the apparatus setup, right? So this is a chemical cell. Chemical cell means no battery. So if it's no battery, just gonna be electrodes with your magnesium and copper with a voltmeter in the middle. So one is copper, one is magnesium, but they will be immersed into their own solution. So here will be CuSO4. Here will be MgSO4. Okay, but how do you relate between the beakers? A salt bridge. Okay, can we say more electronegative? Okay, you want to put more electronegative? Cannot, because table, whenever they give you table, you must use the inert value as an explanation. Okay, must use inert value. When they ask you for explanation, must use inert value. Unless the table not provided. If the table not provided, you can say more electronegative. Okay, more electron, because technically the term more electronegative is not correct right here. Okay, the word more negative is the E naught then. Cannot say more electron negative. Must say more negative E naught then. Okay, guys. So this one, if you draw it out, label it out, should be no issue lah. So this one, everything settled. Okay, now compare the positive and negative terminal of a chemical cell in terms of substance that undergo reduction and oxidation. So guys, what is the process in the cell notation? Usually, if I told you all to do is you go from the top right, magnesium, you go anti-clockwise to the final metal, which is copper, right? So the top equation is oxidation. The bottom equation is reduction. You know why? Because you must lose electron first in order to gain electron, right? So you must lose electron first, gain electron later. So the negative terminal is oxidation. Then the positive terminal is reduction. Okay? So that is what they want lah. So substance that undergo reduction? So who undergo reduction? Who undergo oxidation? So who undergo oxidation is magnesium, Mg. Who undergo reduction is a copper. Okay, but to be more specific, is the copper ion in the solution because he's the one that gain electron. Okay, can so we say magnesium and copper ion. Okay, so but what is the observation? So when magnesium undergo oxidation, what happens is magnesium will become Mg2 plus. So we say becomes thinner. But your Cu2 plus, he will become Cu, he will gain electron, become Cu. So this one you can say round, solid form. Or you can say becomes thicker. Also can, but brown solid form more acceptable lah. And hence, explain oxidation process based on transfer of electrons. So guys, oxidation is about gain or lose electron. So we say magnesium atom lose electrons to form magnesium ion, which is Mg2 plus. Okay, 5 mark, finish. Okay, settle. So this one, guys. So 5 marks here. What you say? So you mentioned who undergo reduction, who undergo oxidation. 1 mark, 1 mark, and then you say observation. 1 mark, 1 mark. You explain oxidation in terms of transfer of electron. 1 mark, 5 marks. Okay, guys. Last question, guys. Congratulations. We are at the last question already, but it's 8 marks. Okay, so now Ahmad uses the apparatus setup in diagram 11 to electroplate an iron key with copper. After 30 minutes, Ahmad found that there is no change at the iron key. He wasted his half an hour, guys. What is happening here? Why got no electroplating happening here? So if you remember this one, when we do electroplating, the copper plate is supposed to dissolve and coat around the iron key, right? Okay. So right now, the problem is what? The dissolving matter must be at the anode. But look at the battery. Battery long one is positive, short one is negative. Anode is positive, cathode is negative. So copper plate supposed to be at the anode. He is placed at the cathode right now. Then the iron key terbalik with the copper plate, the electroplating is not occurring. So what they say, by modifying the apparatus setup, describe an experiment. So guys, what do you do as the first thing is, you have to describe experiment, and then in your description, include half equation. So guys, let's go with half equation first. If you want to do electroplating, you want copper plate to dissolve and coat outside the iron key, right? So at the anode, copper plate will dissolve, Cu becomes Cu2 plus 2E. While at the cathode, the iron key will do the opposite, which is at the cathode, iron key will have Cu2 plus 2E becomes Cu. Okay, so guys, with this, you get 2 marks already. So 2 marks out of 8 marks, good enough. Okay, no need to do anything. Okay, so now what we do is, the last one is to describe experiment, right? Basically, in your overall idea, you just have to make sure your copper plate connect to the positive terminal of the battery and your iron key connect to the negative terminal of the battery. Okay, so what is the steps there? Let me just give you a brief one. So the procedure. First thing, guys, make sure you clean every item. You clean all the stuff. So what about half electron of iron? Half equation of iron? The half equation at the iron key is this. If iron key placed at cathode correctly, the half equation will be this. Because the solution copper, Cu2 plus, he will gain the electron and become back into copper, and he will coat outside the iron key. So iron key, iron Fe not involved in the reaction. Iron key is just there to get protected. Okay, now iron key is there just this to get coated. Okay, so for electroplating, anode and cathode half equation is the balik one. As long you know who is dissolving at the anode, your cathode is just reverse. If today they change it to silver, then here is Ag become Ag plus, then here is Ag plus become Ag. You get the idea? So electroplating actually very easy one. Just make sure you know the anode correctly, then cathode opposite. Don't even care about the iron key. If today I change the iron key to a iron spoon, does it change any equation? No. I change the key to a coin, doesn't matter, same equation. Okay, not. So the item at the cathode is just there to get coated. Okay, so no matter what is the item at cathode, it just get coated. And so what is the procedure then? So usually you have to clean. So clean your what? Clean your copper and iron key. So guys, I never write in the full sentence, just a quick one, okay? Number 2, after you clean, you actually prepare your solution. So you prepare solution is like measure 50 cm cube of 0.5 mole per dm cube copper sulfate, CuSO4 solution, and pour into a beaker and so on. Okay. And then number 3, after your solution prepared, make sure you connect copper plate to positive terminal of battery. Then do the same thing, but you connect iron key to negative terminal of battery. Okay, after everything connected, then you actually dip iron key and copper plate into the solution. Okay, number 6, you just wait. So leave the apparatus for 30 minutes. Okay, guys, just like this. Okay, can so how to get 8 marks? So 2 marks from the equation and then 6 marks from the procedure. Okay, all good. So guys, we managed to finish the whole paper in 2 hours, guys. Actually, you can do less than 2 hours because I do both essay. You realize that? I do both essay. So you in your actual exam, you can just do one essay. But I will strongly suggest, if your exam got time, do all. Teacher will always mark all and take the highest mark one. Okay? So guys, good job on staying awake until 2 o'clock. Yes, guys. Okay. Not bad, guys. There is still 72 of you right here. Okay. From 12 a.m. to 2 a.m. Okay. So congratulations. Teacher, every exam got procedure question. Most of the exam, 99% of question paper got procedure writing one. So always have procedure writing, I would say. Okay, guys. So if you are not my usual student and if maybe you want to ask me question, this is my WhatsApp. Okay, you can WhatsApp me and ask question. I try to reply you as soon as possible. Okay. So next week got that. Oh, next week also you want me to do every week? You all crazy you're crazy every week 12 to 2 I say one can actually on Wow, you guys, you're very semangat when the young is still night, is it? Okay, guys. Next week, got or not, you all refer to GC You all see GC, okay? If GC got, then got. My friend left already. Yeah, guys, they all left already. Now I can watch my FIFA. Okay, so guys, thank you for coming. I appreciate your effort on staying until here. I hope you all got right together, but if you never, it's okay. At least all the info is in your brain for now. So guys, if okay, I will see you when I see you. Thank you, guys. See you next time. Bye-bye. Thank you. Bye-bye. Bye-bye. Thank you. Bye-bye. Good night, guys. Good night. Good morning also. Good night. Good night. Good night. Hey, good night. Good night. See you next time. Wow. All the puns. Okay, I want to ask for the observation, how do I know whether electrode thinner or solid is formed? Okay, for the observation now, you follow the equation. Yeah, so based on the equation now, Mg oxidation will become Mg2 plus. So when atom become ion, it's dissolving, so it becomes thinner. But when ion become atom, it's forming a solid, so it becomes thicker. Okay, so you look at the ion or atom. Ion is solution, atom is better. Okay, unless it's a gas, like H2 is a gas. Then this one is nothing to do with thicker or thinner. You just say colorless gas bubble release. Okay, all good? Okay na, all good na. Okay na. Okay, bye bye, bye guys.